All right, guys, let's take a look at measurement part 5. This is going to take us into metric conversions. Okay, 2 rules when we're converting for our metrics. You always go through the base unit unless you start with the base unit. Okay, so always go to the base unit unless you're starting with base unit. And then the second rule, give the larger unit a value of 1. And I'll reference both of these rules as we're looking at examples. So our first example, 5.23 grams, and we want to know how many kilograms. Now some of you are immediately going to want to give me an answer, but keep in mind, we're working towards a bigger picture. This is just another little piece of the puzzle, if you will, for what's coming ahead. We won't just do straight metric conversions. We will be working with something known as stoichiometry, where you're not only converting between metrics, you're converting between particles, molecules, atoms, ions, formula units. We'll also be able to use this same method when looking at density values and even our gas laws. And that's this process that we're working towards is known as stoichiometry. So we're setting the foundation right now for what's ahead. So on this first example again, I have grams, which is a base unit. So I don't have to go to a base unit first because I'm starting there. So I can go from grams directly to kilograms. And I know that there's 1,000 grams in 1 kilogram. That we had to memorize. That was from yesterday's lesson. So we're going to use a method known as dimensional analysis to set this up. You write what you start with, 5.23 grams. And the dimensional analysis is a fancy way of saying we're going to use a chart so that we can see all of our numbers in units and see what cancels. Well, I know I have to go from grams to kilograms. So to cancel my grams, I have to put grams on the bottom. And then I'm going to convert that to kilograms. So kilograms would go on the top. We're going to give the larger unit the value of 1. Okay, kilo or gram, which one was bigger? Well, kilo, if you'll recall, is above the base unit on your chart. So you know right there that kilo is big, plus kilo means 1,000. So it's going to take the 1. And then how many grams equals 1 kilogram? 1,000 grams is 1 kilogram. Then on your calculator, you would say 5.23 divided by 1,000. That's going to equal 0.00523 kilograms. Please note you have 3 significant figures, and you started with 3 significant figures. So significant figures are in check. And I also included my unit. You must remember your units. If you don't remember the units, those numbers mean absolutely nothing. And I know it's kilograms because my grams canceled out. Let's take a look at a second example. I'm starting with meters, which is my base unit, so I don't have to convert to base unit. I can go straight from meters to centimeters. So I set up my dimensional analysis, 8.32 meters. I want meters to cancel. To cancel meters, it must go to the bottom. And then I want to convert that to centimeters. Well, is a centi or a meter bigger? Centi was below the base unit, so we know centi is smaller. Therefore, the meter takes the 1. How many centimeters were in 1 meter? 100. My meters cancel. Then I would say 8.32 times 100 gives me 832 centimeters. 3 significant figures, and I remembered my unit. Okay, I have 3 little practice problems for you to try. I would like for you to pause the video and go through each of these practice problems to see how you're doing, and then we'll come back together here in just a minute and go over those 3. All right, great. Let's go through and see how you did. For number 1, we're going from milligrams to grams. I'm starting with a prefix, so I know I have to convert to my base unit, which is grams. So I start with 5.34 milligrams. Set up my chart. I want to cancel milligrams, so it has to go to the bottom to cancel, and I'm going to convert that to grams. Now, is milli or a gram bigger? Milli is below the base unit on our chart, so I know it's smaller, therefore the 1 is going to go with the gram. How many milligrams are in 1 gram? 1,000 milligrams is equal to 1 gram. Milligrams will cancel. I would say 5.34 divided by 1,000. That's going to give us there's a decimal right here. 0.00534 grams. 3 significant digits, and then I included the unit gram. On number 2, I'm starting with my base unit, so I'm going to go from base unit directly to milliliters. 2.57 liters. Set up my chart. I want to convert to milliliters, so I have to cancel liters by putting liters in the bottom and then milliliters on the top. Was milli or liter bigger? Milli is below the base unit on our chart, so we know milli is smaller, therefore liter takes the 1. How many milliliters are in 1 liter? There's 1,000 milliliters in 1 liter. Liters will cancel. So 2.57 times 1,000 gives me 2,570 milliliters. This has 3 significant digits. I started with 3 significant digits, so my significant digits are in check, and I remember to end with my unit. I need to recognize, though, that this is 4 places in my number. Therefore, I would use scientific notation, 2.57 times 10 to the 3rd milliliters. Now for number 3, I'm going from nanometers to meters. I started with a prefix, so I know I have to convert first to a base unit. So I have 6.10 nanometers. Set up my dimensional analysis. I want to cancel nanometers, so nanometers has to go to the bottom. And then I want to convert that to meters. Now, is nano bigger or smaller than a meter? Nano was below our base unit on our chart, so I know meter is bigger. It takes the 1. For nanometers, that's going to be 1 times 10 to the 9th nanometers is equal to 1 meter. The nanometers will cancel. I would then have 6.10 divided by 1 times 10 to the 9th. Remember to use your special EE or EXP or 10 to the N button when you enter that. And once you enter it, you should get 6.1, excuse me, 6.10 times 10 to the negative 9 meters. I started with 3 significant digits, I end with 3 significant digits, and I remember to include my unit. Okay guys, now we're going to take a look at two-step metric conversions. Looking at our example, we have 8.43 centimeters, and we're going to convert that to millimeters. This is where we're going to use both of our rules. We're going to go from centimeters. We have to go to the base unit first, so you would go from centimeters to meters and then to millimeters. So a two-step problem. This is also setting us up for something we're going to do in the future known as stoichiometry, where things start getting a little bit more involved. So looking at our example here, again, we're going to go centimeters to meters and then to millimeters. I still use dimensional analysis, 8.43 centimeters. I set up my dimensional analysis chart. I want to cancel centimeters, so centimeters goes to the bottom. And I'm going to convert that to meters. I know that 1 meter is equal to 100 centimeters. That allows me to cancel my centimeters. I'm now going to go from meters to millimeters. So again, I'm going to extend my chart by 1. I'm going to put meter on the bottom in order to cancel, and then millimeter on top. I know that 1 meter is equal to 1,000 millimeters. My meters would cancel. When I calculate this, I would say 8.43 divide 100 times 1,000. That gives me 84.3 millimeters. Let's take a look at another example. We're starting with micrograms and we want to go to kilograms. So again, I have to do a two-step problem because I don't have a base unit here. I would go from micrograms to grams, then to kilograms. So starting with 0.532 micrograms, I want to cancel the micrograms, so it would go to the bottom. And I can convert that to grams. I know that 1 gram is equivalent to 1 times 10 to the 6 micrograms. This allows for the micrograms to cancel. I now have grams, but again, I want to go to kilograms, so I have to cancel grams by putting it in the bottom. And then I would convert that to kilograms. For every kilogram I have, 1,000 grams. The grams would cancel. I would now say 0.532 divided by 1 times 10 to the 6, divide again by 1,000. That's going to give us 5.32 times 10 to the negative 10 kilograms. Okay guys, I have 3 practice problems for you. If you would pause the video, work these 3 problems out, and then we'll come back together to check your answers. For this last practice problem, note you have a little hint right here. Okay, here's our first one. We're going from kilograms to decigrams. So I know I have to go to base unit, kilogram to gram, and then to decigram. So I'm going to set up my dimensional analysis. I have 100.6 kilograms. I want to cancel kilograms, so kilograms goes to the bottom so that I can cancel. And I want to convert to grams. Got to go to the base unit. There's 1 kilogram for every 1,000 grams. My kilogram would cancel. I now want to get rid of grams, so grams would have to go to the bottom to cancel. And this time I'm going to convert to decigram. The gram is larger, so it takes the value of 1. How many decigrams are in a gram? Remember, think decidime. There's 10 decigrams in 1 gram. My grams would cancel. This time you would say 100.6 times 1,000 times 10. And when you go through and calculate, you would get 1.006 times 10 to the 6. I'm running out of room. I'm going to rewrite that answer down here, sorry. 0.006 times 10 to the 6 decigrams. For our second example, we're going from milliliters to nanoliters. So milliliter to my base unit, which would be liters, and then to nanoliters. So I set up my dimensional analysis, 8.43 milliliters. I want to cancel milliliters, so it goes to the bottom. And I want to convert that to liters. There's 1 liter contains 1,000 milliliters. Milliliters would cancel. I now have liters, but I would like to go to nanoliters. So to cancel my liters, it would have to go to the bottom. Liters would go on the bottom, and then on top, the nanoliters. Always remember nano and 9, N and N go together. Nanoliters would be 1 times 10 to the 9th nanoliters is equivalent to 1 liter. My liter would cancel. To enter this on my calculator, it would be 8.43 divided by 1,000 times 1 times 10 to the 9th. When you calculate that, you would have 8.43 times 10 to the 6 nanoliters. Then our last one is 2.30 centimeters cubed going to hectoliters. And I had a hint underneath on this problem. I told you that 1 milliliter is equivalent to 1 centimeter cubed. So if I had 5 milliliters, I would have 5 centimeters cubed. If I had 18 centimeters cubed, I would have 18 milliliters. They are equal. I know my goal is to get to hectoliters. That's my goal. Well, centimeters cubed is not the same base unit as a liter. So that makes me think, okay, wait, I got to get rid of centimeters cubed. I'm going to need this conversion. From centimeters cubed, I have to convert that first to milliliters. And then once I convert it to milliliters, then I can go to my base unit liter, and then from liters to hectoliters. So this one has an extra step added in. So starting again from my dimensional analysis, 2.30 centimeters cubed. I want to cancel centimeters cubed, so it has to go to the bottom. And I'm going to convert that using my conversion factor here. This is something you guys have to memorize, to milliliters. And we said they're equivalent. 1 milliliter is the same as 1 centimeter cubed. This allows my centimeters cubed to cancel. And some of you are thinking, well, why do we even have to put that step in there? Again, you're setting up some practice so that when we're working with density, this will be second nature to you. You'll know to do that. And plus, it's the only way that you can cancel centimeters cubed and convert to milliliters. Now I have milliliters. I want to cancel milliliters, goes to the bottom, and I want to convert that to liters. 1 liter is equal to 1,000 milliliters. Milliliters can now cancel. I can now cancel liters by moving it to the bottom, and then I can convert that to hectoliters. When I look at my values, I know hectoliter is larger. 1 hectoliter is 100 liters. My liter can now cancel. You would have 2.30 divided by 1,000 divided again by 100. And I hope you guys caught that, because you've got to divide twice here. 2.30 divided by 1,000 divided by 100. When you punch that in, you should get 2.30 times 10 to the negative 5 hectoliters. All right, guys, bring your questions to class. We will do more practice with this, but make sure that you are memorizing those prefixes.